So welcome back, Level 1 NCEA Physicists. Today we're looking at reducing heat loss, reducing thermal transfer, heat transfer. So we look at the heat losses from a standard house. You can see that about 25% of heat is lost from the roof, 35% from the walls, 15% basically going into the ground, and about 25% from your windows. So how do we reduce this loss? So basically the way to do that for the doors, you can use draft excluders, basically at the bottom of the doors to stop air getting in and out. Windows can use double glazing and curtains. The roof can use insulation, like pink bats. Floors can have carpets, and the walls can have insulation inside the walls themselves, inside the wall cavity. An example here where we use science or the physics principles of heat transfer to reduce heat loss from liquids, or at least heat transfer, where a thermos can keep hot things hot and cold things cold. And the way it does this is through three methods. So for stopping the conduction of heat transfer, it has a vacuum between the liquid itself and the outer layer. Okay, it also has a stopper. Okay, and also a cork and air spaces, because remember air is an insulator, so it's harder for the heat transfer to occur by the conduction, by basically surrounding it with insulators. In order to reduce the heat transfer by convection, again we have the vacuum, okay, so there's no particles, so it's impossible for it to occur by convection. Again the stopper, and also the trapped air spaces again, okay, because again we've learnt that air is a very good insulator when it comes to transferring heat, very poor at doing it. And finally, to kind of stop heat transfer by radiation, we reduce this by having the silver glass walls, because we learned in the previous lesson that shiny surfaces, which are light colored, basically reflect heat energy back when it's being radiated. They're very poor emitters of heat. So just reinforcing that, so the outer cap or cup basically reduces conduction and convection. Okay, the plastic cap reduces again heat transfer by convection and conduction. The shiny mirror surfaces on the inside actually of the thermos and also the outside reduce heat transfer by radiation. And the vacuum, because there's no particles in the vacuum, mean conduction and convection heat transfer doesn't occur at all. Sponge reduces conduction. The air, because it's an insulator, reduces heat transfer by conduction. And the plastic case, again, because plastic is also a very poor insulator, reduces heat transfer by conduction. So going back to the house example, draft excluders basically don't allow convection currents to occur, so there's less heat transfer by convection. The double glazing, because there's a vacuum or air between the two glass layers, means that conduction and convection heat transfer is reduced. Reflecting strips behind the radiators, again, so it's reflecting back the heat energy by radiation, so that's going to reduce radiation heat transfer. Loft insulation, again, conduction and convection is reduced because the loft material is an insulator. Carpets, again, because carpets are made of insulating material, reduce the heat transfer by conduction into the ground. And cavity wall insulation, again, because it's an insulator inside the cavity, is going to reduce heat transfer through the walls by reducing conduction and convection. So those are just some ways, practically, that we can reduce heat transfer by the three methods that we've been exploring in this unit.